Okay, hello everyone, and thank you for being here. Welcome to the 8th season of our Smart Talk series called Kenya Smart Metering Moment, Challenges, Policies, and Pathways. Today we will talk about an important step in Kenya's energy sector. As Kenya moves forward with smart metering, utilities and institutions face both new opportunities and real challenges. Smart metering helps utilities improve grid operations, reduce losses, and offer better service to customers. It also supports the use of renewable energy and better energy planning. However, success depends not only on technology, but also on good policies, clean data, and strong cooperation between all stakeholders. Today's discussion brings together experts with practical experience, research and policy knowledge, and a global view of the energy transition. We will look at where Kenya is today, what challenges remain, and which pathways can lead to successful smart metering projects. Please welcome our guest, Mr. Cleophas Ogutu, Project Manager for AMI and GIS Data Cleanup at Kenya Power and Lighting Company. Welcome, Cleophas.
Thank you, Jovan.
Mr. Jeremiah Kiplagat, Director at the Institute of Energy Studies and Research. Welcome, Jeremiah.
Thank you, Jovan. Thank you for having me here. Thank you.
And Mr. Daniel Bungi, Future Energy Leader at the World Energy Council. Welcome, Daniel.
Thank you, Jovan. Thanks for having me here as well.
Okay, thank you for joining us today and welcome to Smart Talks. Let's move on to the questions. And before that, I would like to encourage everyone in the audience to actively participate by sending questions in the Zoom chat throughout the webinar. So, first question which we will discuss today is, what challenges do you think Kenya might face in achieving full smart meter coverage across both urban and rural areas? Cleophas, maybe first to start with your answer, considering your role as project manager on various smart metering projects and experience implementing AMI systems.
Thank you very much, Jovan. I also welcome my fellow panelists and the audience. On the specific comment on the challenges affecting full implementation of smart metering, and with special emphasis on what would be the challenges in rural and what would be the challenges in urban setup, we just want to highlight a few cases. In urban sectors, most of the time that is where we have the elites. Generally, creating changes for the elites becomes a challenge. It's a matter of embracing new technology. And what are some of their concerns? Some of their concern is that with the deployment of smart metering, there'll be element of privacy infringement by the utilities, whereby if you incorporate that one also with the aspect of data analytics, obviously you will know somebody's routine and the patterns on when they are present in the house, what they consume and all that. And also coupled with the elements of technology. Technology in terms of the complexities of the systems that we will require vis-a-vis incorporating the same in urban setup for the customers who are there. In the rural setup, what really comes into my mind is how densely are the meters which are targeted to the customers how densely are they populated? Now that comes, they are sparsely distributed generally, and that comes now with the challenges of now the investment that you need to reach to be able to bring on board customers who are not densely populated. There'll be a very huge investment insofar as bringing those ones into smart metering platform, but the return on the same, considering the sales that the utilities realize in the rural setups, is a bit low. So those are the differences between the challenges that we face as a utility insofar as bringing the urban and the rural customers on board. Thank you.
Okay, thank you, Caiaphas. Jeremiah, what challenges do you see?
Thank you. I think maybe to add with to what Cleophas has talked about, I think he mentioned about rural areas and urban area differences. The biggest challenge, in my view, is also related to that is financing, because smart meter require high upfront financing cost, especially if we were to deal with legacy meters and we're replacing them. So the capex, the upfront capex is high. And also the rural areas, they have weak payback, business case, because you find some of the loads or consumption in rural is very low. And if the cost of communication is high, then sometimes it doesn't make sense having smart meters in those areas. So that brings in the issue of connectivity, which I think Eliof has mentioned. The cost of data, if you're using cellular for connectivity, that becomes very expensive. Currently, we are paying, I'm not sure, maybe 100 shillings or 50 per meter per month. And when we scale this up to 10 million customers plus that we have, it will be a huge significant cost. And you realize this cost is not recovered from the tariff. So it has to make cost efficiency in that it should address losses, and that cost in somehow being covered. You are reducing the cost of addressing, if you are using people to check for theft and all that. If by deploying smart meters, that cost can be offset, then it can make a good business case. The other issue is the grid. We find that our grid is old and sometimes unstable, fluctuations. It needs to be renewed, and when there are these can damage the smart meters. So what we need, we have a challenge is also modernizing the grid so that it goes as a system. We cannot look at the smart meter as an end in itself. Before that, the grid must be stable and must be modernized. And this is the other big challenge that also it needs to be worked out together to push it so that the meters can be safe and it can work better. You can now deploy other IoT technologies so that these smart meters can be helping in running the grid when there are outages, managing all that, then it makes sense. But if the grid is old, is unstable, then it becomes an issue. The other data and cyber risks. So this, when you have a lot of smart meters, it requires a strong IT and security system. So this also needs to be looked at so that the data is safe and also it can assure that security and ensure that nobody can intrude this and maybe tamper with the meters. The other one, which also is under my domain, is the skills gaps. These IT and OT systems require convergence of analytical skills and capacity to really make proper use of the data. Because what we are looking at is the data, how to manage that data, and also to ensure that it is bringing value to the business as such. So I think in addition to what Clover said, those are a few additions that I have made, which affects us even as we are thinking of rolling out to full smart meters. Thank you.
Okay, thank you, Jeremiah. You mentioned a lot of issues for further discussion. Now, Daniel, do you have to add something on this first question?
Thank you, Jovan. I think my colleagues have aptly presented some of the critical issues that would be considered challenges when rolling out smart meters in Kenya. And especially, I think what they've highlighted is on the characteristics of the users when it comes to urban areas and rural areas. The differentiation is quite contextually driven. So an additional point for me would be more around the user perspective. I think there's also a social-cultural behavior challenge that would have to be considered or taken into account, considering that you are driving change in terms of bringing in a technology solution. So beyond the technology, the finance, which is being driven by what Jeremiah has presented on, what are the cost-benefit analysis, is how do you ensure that you are able to drive the right behavior when it comes to the users, and especially them being open to taking up such a kind of solution without the resistance that would normally come with introduction of technological solutions. There's the sensitivity towards smart metering tools as potentially, surveillance tools, or looking at it from a perspective of having a better understanding from a utility of a user. What does it mean for me? Or really, some of the key challenges that the utility grapples with has to do with trust and behavior. That would also be a challenge to try and shift. So that dimension of sociocultural dimension of driving change is critically important as much as the technology, finance, and the policy would be.
Okay, thank you, Daniel. Jeremiah, regarding the fact that you are director at the Institute for Energy Studies and Research, and you work on energy research and utility development and have very strong experience in innovation. In your previous answer, you mentioned a lot of issues, financial, technological, and regarding the human capacity. So because that, I would like to address first to you the second question. What do you see as the biggest barrier to successful smart metering between financial, technology, and human capacity issues you mentioned? What do you see that it is the biggest barrier?
Thank you very much. I think, as I mentioned, in my view, the biggest is the financing. The financing, because what we are doing now is, of course, we are rolling out smart meters. We are to replace, so we are buying only smart meters as a way so that we can progressively replace the old meters which have failed and deploy new smart meters. So we are funding through our regular budgets. But for impact, if we need to do in mass, then the benefits are long-term. Costs are upfront. Of course, the desirable thing, which Cleophas will tell you, is To help us address losses and many things, we need to convert to smart metering in mass. And when you do in bits also, it may not help. You still need the same meter readers. Then it's a mix. We have the old meters, we have the prepaid and smart mixed together. But if in an area you convert purely to smart, all of them, then there you would treat it differently. But as long as we are growing it, progressively, then you still need a meter reader because some meters are still there. Someone has to still go. You have not dropped that cost. And many other, the issue of losses, again, you still need to go and inspect. A visit there, okay, you're not benefiting purely from the smart meter because it's a mixture. So ideally, it is to, convert in scale, go to an area, change to smart meters. But that brings in the issue of cost because you recover this it takes a long time, and the tariff doesn't provide for this. So again the other challenge is bankability because, as I said, as we roll out the smart meters, it is creating costs in itself. The cost of communication is there. So that has to be factored in. So if we do again, even for very low consumers, then you find that the cost of data is too expensive, to recover. It has to be subsidized by a large consumer, so to say. So that cross subsidy, so that to have a bankable case is not easy as such. So that's why what needs to be addressed concurrently is also the issue of connectivity. How do we have very cheap connectivity for these smart meters? And that's why this area where we are scrabbling to develop, maybe, is it the what we call the communication using the power lines, RF mesh. Now in Kenya, we are rolling the digital superhighway, connecting fiber literally to be almost everywhere it comes to government institutions. And so progressively fiber is getting reached to almost every part. Can we capitalize on that? And how can we put together these various communications technologies to give a lower cost, the lowest cost in the long term? So that is the big thing in myself. As I say, the skills can be developed, can be built. Technology itself is not a risk, it's proven. So no major challenges in technology. But on financing also, I say you need also to upgrade the network so that we have better power quality. Sometimes when there are faults, what you realize is it goes back to the meter and it kills the meter. It burns the meter. So that again is a cost. So progressively, as we roll out the smart metering, we should also pursue smart grid and upgrading so that we have a more reliable power infrastructure as such. Thank you very much.
Okay. Daniel, what do you see as the biggest barrier and how would you address it? And maybe because you mentioned users, human, maybe you can mention about human capacity. How do you see that barrier?
Yeah, thank you, Jovan. I think it's a combination of issues for sure. But what would come out as the top barrier would be the financing. I think, as Jeremiah put it earlier, presenting a solid business case for replacing meters or overhauling an entire metering space within a given context especially within areas that are not metered right now, which happen to be areas that have the characteristics that have been defined as low cost, low energy consumers. Building a solid business case to be able to attract the right funding is one big challenge, and that needs to be addressed. And then when you look at also the utility itself, it has evolved over several years, and over these years there have been systems that have been established, considered as legacy systems. And all these systems, of course, exist within contractual obligations that have to be, adhered to, and potentially, if you look at it, sometimes it's quite prohibitive to try and overhaul an entire system existing in this kind of context. On specifically the human capacity, I would say the people focus for successful implementation of any technology system, being that even smart meters is a socio-technical system. You would look at it two ways in terms of driving the change from the user perspective, and also building the internal capacity and the inertia to drive the change. So I think these are things that will need to be addressed. Of course, cognizant of the fact that the utility itself has within it talent of people who have been able to sustain the existing systems. As much as you'd report and say there are losses, there have been people who have been able to make do with the systems that exist, and they have been able to innovate internally to drive that change. So I think enabling this capacity, both internally and also driving the consumer change from potentially a political level, public level awareness is also important to be able to address this barrier. So I think all this, if you look at it collectively, the challenges would be viewed from sort of a policy, the need for a coherent connecting policy at the national level that enables the utility now to operate within all these circumstances. I think another barrier that's been also mentioned by Jeremiah is really availability of a low-cost technology solution that can fit some of those characteristics and contexts that have been described. When you look at most of the solutions that exist, they are built with either the global north standardization, which of course fits the evolution that the utilities in this sector or in this geographical space have gone through. So getting the right partnership of vendors that are willing to partner with the utility to innovate and to build solutions that will be contextually fitting is also likely to be a barrier, because you would not be able to do that without any policy incentives that provides that to these vendors to be able to come in and take up the risk of working with the utility to innovate, to think outside the box, and to build solutions that will be contextually fitting.
Okay, Daniel, thank you. Cleophas, what do you have to add on this? What do you think? What is the biggest barrier? How would you address it? And maybe if you can add about connectivity. Jeremiah mentioned that, and what do you think is a power line communication solution for that? Or please.
Thank you very much, Jovan. Allow me not just to add, but also to emphasize some of the points and maybe contextualize or repeat some of what my colleagues have said in a different way. The first greatest barrier to smart metering, as that has been said, is financing. And what will be the way forward, in my view? And what exactly are we financing if we are talking of that? Please allow me to expand a little bit on this by exploring the three key blocks of smart metering and trying to tie it with the financing. The very basic three blocks of smart metering are the smart devices in the field, the telecommunication, and the system. Now, for the smart devices in the field, you need state-of-the-art meters, which are going to help the utilities on matters tamper-proof, which are going also to be very, very much robust in terms of withstanding the weather patterns there, and also going to be very convenient for the customers. Now, if you take all those aspects into cognizance, the kind of a meter that you will define or you will design in the utility to meet those key basic parameters is a meter that will be expensive. It will not be very cheap. Now, the second aspect is also what has really been emphasized insofar as telecommunication is concerned. If you remember very well, the director Kiplagat hinted on to us right now, the very effective telecommunication mode that we are applying in Kenya is cellular, the GPRS. Now, going by what we've had for almost like 10 years now, the cost of a SIM card or for 1 meter communication in a month is around $1. He talked of 100 Kenya shillings, but it's around there per meter. Now, I want you to look at our utility where now we are having almost 10 million meters, and you've already made a declaration, or it has become a policy, that now we are going to have all those meters being in smart meters. You multiply $1 by 10 million of those meters, and you just find it is costly, and you need a lot of investment as a utility to be able to decommission that mass of meters and convert them into smart. And when the process of commissioning also comes the cost of doing so. Who has the skills? How do you hype the skills to be able to do that? Who actually is going to meet the cost of that decommissioning? How do you handle the existing contractual matters when you are doing that? Then finally, you go to the system itself, where this data goes and being processed, and you get back what you have actually manually read on the meter. If you go there, basically the bare minimum I need in a system is a reliable system, a scalable system, and an open system, a state-of-the-art system which is able to incorporate all those three aspects. It will come with licenses, it will come with operational cost, it will come with which technology do we adopt and how do we keep in pace with rapid changing technology. I can adopt a certain system today. The following day, a lot has been done in that line, and the system becomes obsolete. Besides, how do I incorporate the legacy system into this? How do I keep up with the pace of technological changes, even as I adopt smart metering? So the financing aspect of smart metering needs to look into all these three key blocks and the dynamics which are involved in it. I can assure you, for a utility, that is a totally difficult aspect, considering that their work, and maybe our work, for instance, is to distribute and sell electricity and have a profit on what we are doing. So what comes to me as maybe what would be a solution, which is also a part of partnership, is for the utilities to go the way of public-private partnership. That will be a game changer insofar as meeting these desires of meeting the huge cost of deploying smart metering. In the public-private partnership arrangement, these cellular companies, which are basically just getting something from us out of the month, they can become our partners. And then we have a long-term way of benefiting, whereby each and every month, it's a small portion, differently from what we are paying now. There's also the element of where people can go to concessional loans, and maybe also the commercial banks can also get into the utility as their customer, they should not just wait for business people. Utilities are equally very, very business kind of. And the utility should also find a way of influencing the banks to see them as potential customers. Something that also crossed my mind, and maybe this might be different from what has been said before, Jovan and my team, is the element of roadmap. What do we start with insofar as smart metering is concerned? I've highlighted the basics, but the other additions into smart metering are things to do with the GIS, things to do with the advanced technologies in matters data analytics. So what is the best roadmap insofar as deploying the smart metering is concerned? Because again, if you don't get that one right, then it becomes a very big barrier. So financing and the roadmaps, that is what I can say for now, insofar as that is concerned, over and above what my fellow panelists have talked about. Thank you.
Okay, Cleophas, and thank you for this concrete suggestion. Interesting for discussion. Okay, now we could continue with the third question. From a global perspective, what role should policy alignment and institutional collaboration play in transforming Kenya's pilot projects into national-wide smart metering program? Daniel, through your work in the World Energy Council, you engage with energy leaders and institutions across different regions and markets, supporting long-term energy transition. So maybe you can first give your answer on this question.
Sure. Thank you, Jovan. I think addressing these challenges and barriers that have been highlighted needs strong policy alignment. And if you look at any successful technology transitions, right from pilots to scale, there has to be really a policy level supported program that hangs around what has been even mentioned by Cleophas as building or providing a roadmap. So in Africa, this is more specifically important because, as we said, the challenges that come with having to work with scarce finance or competing needs, aging infrastructure or legacy systems, and the fact that you have a characterization of customers that have affordability and sensitivity to different technology options, then the policy has to provide an enabling environment for the utilities to experiment within these constraints. And I think when you look specifically within the African continent, what's been happening is there would be initiatives within the electricity sector that are aimed at improving the performance of the utilities, either from an efficiency perspective, maybe introducing renewable energy integration and net metering policies, or looking at it from a direction of providing more power to be able to catalyze socioeconomic development. When you look at all this, the connecting thread would be a policy agenda at the national level that is able to now build and bring together all these pieces of these requirements for collaboration, either with vendors, putting in place the regulatory mechanisms that incentivize and ensure that they're able to work with the utilities to bring about a requirements balance that can build result in technology solutions that are contextually fitting also to the characteristics of the users, addressing and meeting the needs of the users from an affordability perspective, or also fitting business case and the evolution that the flexibility of evolution that these utilities have to go through. I think a national policy roadmap is quite important because it also brings about how it connects to other sectors of the economy. If you look at education, if you look at telecommunication, when bringing in the mobile network operators, when government is building initiatives that have been highlighted, for instance, around maybe digital superhighways of connecting institutions and potentially eventually homes to fiber network, how does this connect to the overall roadmap for the sector? So I think it is very important. I think the overarching importance of policy could not be understated because it connects all these pieces. It equally brings about the confidence that the financiers need to be able to put up the money into PPPs. Some of the constraints that we see with public utilities or majority state-owned utilities in Africa trying to pursue this path of financing is they tend to be limited sometimes with policy constraints or that do not really clearly support this agenda. So I think that is also equally important because it will also be able to unlock that opportunity to be able to address the challenge of finance. Lastly, I think a policy that connects to an overall agenda to say manufacturing is also equally connected to smart meters because one of the biggest challenges that is faced, of course, right now in Kenya, equally in Africa, is the problem of limited jobs for the young people. And manufacturing is premised as one of the sectors that could catalyze or provide jobs. When you look at how this connects to manufacturing is that if we are able to provide a policy framework that even encourages local manufacturing and local production of smart meters, then you're able to indirectly address the issue of jobs. So the policy that would be able to look at not only pushing electrons through the wires to drive socioeconomic development, but to catalyze the interconnected system is what would really be able to drive a shift from where utilities are experimenting to pilots to scale and to be able to drive an overall agenda of smart metering.
Okay, Daniel, thank you. Cleophas, what is your opinion about this subject?
Thank you very much, Jovan. I would like to look at this aspect in terms of who really formed the energy or electricity sector. And I will give it the Kenya scenario. We are working in an environment where the energy sector is unbundled. So we have the generator, we have the transmitters, the transmission company, we have the distribution company, and then we have another aspect that deals with the renewable energy. We call it REREC here. And then to ensure that we get harmony and serve people well, we have the regulator. So one of the things that I really want to highlight is that there's a very big need for strong collaboration from all the parties that are involved in the energy sector. And look at that Kenya, for instance, where you have the generator on their own, transmission on its own, distributors, another government-owned company that is dealing with renewable energy. And then you have the regulator who are supposed to bring all these people together. So one of the key things that needs to be done between all these key aspects is a very strong collaboration so that there are very clear policy from end to end insofar as data privacy will be concerned, insofar as matters to do with the grid resilience and grid modernization will be concerned. And by extension, this strong collaboration should also result into how we set the tariffs. I've seen very, very interesting scenario where most of the burdens of these or failure to have this strong collaboration ends up being a heavy load on the back of the distributor. Because like a distribution company like ours, we are the ones who are directly dealing with the customers. And even the regulator does not deal with the customer directly. So all the things that will happen as to cause power and reliability, poor quality of power, the person who bears the burden is the distributor. And the distributor is also limited into what they can say insofar as the other players in the unbundled environment sector is affecting them. So strong collaboration, and definitely unbundling is okay. It also creates a specialization, and it also creates a lot of reliability, and it creates so many other positive things. But strong collaboration, we should not disbundle and fragment, right? Even when we unbundle, we should know that what we are doing is somehow connected. So there should be a very strong collaboration between the key players so that we are able to serve the people who benefit from the power sector well. Lack of that will just means that that kind of fragmentation, especially when the energy sector is unbundled, will derail even the process of uptake of smart metering. We've seen different scenarios where a distribution company would want to follow their energy all the way from the generation to transmission to the distribution. And then there are these key distinct blocks. So the person to unlock this is the regulator, for that matter. And for the regulator to unlock that, the key sector players must also have strong collaboration so that we are able to work together to work well in a sector, energy sector, which is unbundled. Thank you.
Okay, Robert, thank you. Jeremiah, what do you think about this subject regarding policies and collaboration between institutions?
Yeah, well, I think my colleague have really explained a bit. Perhaps to just add is maybe in policy, the smart meters need to be classified as a core grid infrastructure so that it is there in the policy. And sometimes because of customers fearing, billing abuse because they are also greater data surveillance, they can resist the implementation of smart meters. So when it is in the policy, then that gives it and reinforces it and for implementation. The other is institutional alignment of the energy, ICT and data protection rules and guidelines also be aligned to be able to support effective implementation. So I think so generally what is important also is collaboration to ensure that there is proper standards to support the deployment of the smart meters. And also to emphasize what my colleague said is lowering procurement costs, what needs to be done. Can local manufacturing address that or support in ensuring that the cost of meters are also not too prohibitive to enable the deployment at scale. So I think those are the few comments I have on this. question.
Okay.
Yeah, thank you.
Okay, Jeremiah, thank you. Okay, so after this discussion about smart metering, maybe we can now expand a little on smart grids discussion. And what factors do you consider essential for the successful implementation of smart grids in Africa, in Kenya, and especially in countries with rapidly growing electricity demand? Cleophas, you mentioned renewables, so maybe you can first give your opinion on this.
Thank you very much. The first very key factor that comes into my mind when you are talking of smart grid is the competition that we have insofar as energy sources are concerned. So the smart grids of today, sorry, and the effective ones for that matter, should be able to successfully integrate renewable energy. That is very key. The smart grid should also be incorporated and should be able to, utilities should also be able to invest on energy storage. And the smart grid also is automated. So there should be a very strong element of a digital backbone that is able to support the data exchange, that is able to ensure that we get alerts as required, that is able basically to make the reality of what would be called a smart grid be relevant to what it is expected to do. So integrating renewables, investing in the storage, and having a very strong digital backbone that is able to support on data exchange is key. Those are key factors that needs to be checked for a robust, efficient, and reliable smart grid. Yeah.
Okay, Jeremiah, what do you think about smart grid?
Yeah, on the smart grid, the concept of smart grid in itself, I think the beginning point is to fix the grid, then digital second, because the wires must be working well, having robust designs and equipments. To me, I think that's the first thing that should be really done. Once that is done, then adding this, making the grid smart, then will be more valuable. He'll have more benefits now in terms of automating and bringing in the software part. And this is, so if we talk of smart going the digital without fixing the actual grid, the reliability issues, making it strong, upgrading, then we may not realize the full benefits of digital, smart grids. And the other things, of course, and basics is the having data systems in place, such as SCADA, ADMS, DERMS, and cybersecurity as also the basic that it needs to be there, which can enable the smart grid deployment of making this grid more digital. This involve investments, and always they need to be predictability in terms of returns and clear rules when it comes to partnerships, collaboration, clear roadmap. So that is also important when it comes to the regulations clarity in terms of rules. Predictability also is clear when investments are done. What is the expectations? So that is important to enable the smart grid deployment. Maybe, of course, the other part is human capacity, which is also critical in power skills and digital skills. So this is important. So that when you deploy, it can be supported effectively. You have capacity. Human capacity is a very critical as well. Yeah, maybe I can stop there. I think those are few.
Okay. Okay, thank you, Jeremiah. Daniel, what will you add?
Yeah, thank you. At the risk of course, of emphasizing some of the things that have been mentioned, I think having a clear roadmap in place, which is equally what was mentioned about smart metering, is important because it connects all the things from the technology, the infrastructure, the readiness, the regulations, and financing. And I think it is important to build upon components of scalability and adaptability, which demands that you build premised on the current system. So, as Director aptly put it, is that the understanding of the current system, how it looks like, how it's structured, is important to be able to now incrementally build upon to drive it towards being smart. And I think a long-term plan or a roadmap that enables this view and understanding of where the sector is going towards. Because if you look at it, there is the evolution towards electrification of everything. There'll be electrification of transport. So the sector will be experiencing more demand in terms of driving aspects of living when it comes to transport, when it comes to heating, when it comes to cooling. Therefore, all these demands of a system that is flexible and being able to support this system with the mix of sources and even interconnection across borders. There has to be a coordination. There has to be uniformity of rules even across borders. So I think a national level and a regional level roadmap that enables Kenya, for instance, to be able to drive the smart grid implementation in a manner that will work with maybe Tanzanian rules or Zambia rules in future is important because it gives that foresight and enables the utility to build the pieces of whatever will be a bigger a block of operation.
Okay, thank you, Daniel. Next question is how can data and artificial intelligence reshape the way we manage energy systems in the future? And if you have any example about artificial intelligence or smart grid interest in Kenya, please mention. So Jeremiah, maybe you can first give your answer.
Thank you. Data and AI is the future, actually, of energy systems. And AI turns the grid from being from reactive to predictive. So this will provide transformation in terms of predictive maintenance and outage prevention. So this will aid in, having proper planned maintenance works with support of AI and data, which now it can make the grid more reliable. We don't wait until the poles fall, then replace them. The other one is we have demand response instead of network overbuild. You're able to now expand or do what we call decisions based, which are driven by data. And when this is done, you can have faster decision making in the utilities. Also, when there is enough data, you can invest, proper investment decision can be done, and that can lower also OPEX, the operational costs, make the grid more better. The other one is increase accuracy in demand forecasting. When you have renewable energy sources that you need to forecast, because of these AI tools, you can have better forecasting and also have better dispatch activities to optimize dispatch for cost effectiveness. Maybe another one is, of course, real-time monitoring, which helps in loss reduction and theft detection. So it can help fight losses in a better, more intelligent way. And this way, the utilities can have better savings and revenues. So also the digital twins can be of great help when dealing with planning and operations. You're able to do simulation work, see how the grid performs in different scenarios. And so it helps in enhancing skills and better understanding of this network power system. Yeah, thank you. I think those
Okay,
are...
okay, Jeremiah. Thank you. Thank you, Daniel.
Yeah, I think Jeremiah has really captured some of the essential components of AI in terms of energy management and what it looks like renewables into the future. I think the other view of it or dimension of it is the fact that AI in itself will be a driver of consumption, and running AI models and will require IT infrastructure, require building of data centers, which will be also driving consumption, as will be taken into consideration in terms of energy planning. And on the side of what it enables in terms of what utilities will be seeking in driving efficiency, I think it's been well mentioned that it will support demand forecasting, electrification planning, operation, including integration of bigger shares of renewable energy, and even the agenda of electrifying everything, being able to flexibly balance the grid. So all this may sound idealistic, but in terms of really some of the low entry points for utilities, if you look at Africa, for instance, there's a lot of estimation of billing that is done as a practice by different utilities, and it's premised on analyzing bills of customers over a given period of time. So it's within, of course, what human judgment and capabilities could. If you look at AI in an environment like this, it enables better decision making when it comes to even things like billing, and even understanding customers and being able to serve them better. So some of the cost drivers being that you have to either have invest in workforce to be able to manage your system or relay customer support components and services that could actually be supported by AI tools. So there's all this myriad of things that AI can support when it comes to utility efficiency and lowering cost across the board, across from the operations, from the customer service, from the technology, from maintenance, and even being able to really allow for data-driven design of services and even inform the policy level in terms of behaviors and understanding of where incentives could be driven for different consumers. And I think even as utilities think about coming up with dynamic pricing and time of use tariffs, these AI models would really be useful in enabling them to have the right, the most precise way of doing that.
Yeah, okay, thank you. Interesting and useful example. And Cleophas?
Thank you very much, Jovan. When it comes to the topic of data and AI in a utility, that is a game changer. And I think that should be a whole webinar on its own. But for the sake of what we are doing today, let me join my colleagues by emphasizing that in the age where we are now, this is now an inherent part of the utility, apart from just being a game changer. And I think, as the director had said, and Daniel has also said, reliance on data and matters AI helps utility in predicting demand, predicting where we are losing theft. And on the customer side, and also we rely on it in empowering the customers to be able to, on a real-time, interact with us and be able to even manage their consumption. Besides that, the aspect of the evolution of data and AI also brings a very key aspect in a utility where it brings about interactions and also brings customer loyalty and also brings an element of integrity. Many a times, lack of data and exposure of exactly what you are doing to the customers brings suspicion, and even a correct bill for that matter might be suspected. So when I'm talking of this data and AI transformation in utilities, it brings about that kind of element of collaborations, interactions between the customers and the utility. And by extensions, if we might put it lightly, but lack of that evidently has brought a lot of disputes for many utilities that go for a prolonged period of time, cost a lot of money for that. So that's why, to me, it's a game changer in so many utilities, and it is something that utilities must embrace. Now, we are talking of data again and artificial intelligence. I like the fact that this thing is called artificial intelligence because there's another intelligence in the name of human beings who speaks to now what would be sustainably and using computer methods qualify now to be called artificial intelligence. Who is the first person who inputs something that will be simulated, will be correlated with other things for us to have now what qualifies as an artificial intelligence? It is the human being. So to what extent will you be able to make these people ready to have or operate in a utility that aspires to embrace data and artificial intelligence? Data and as artificial intelligence being embraced by utilities has brought a very different scenario where if I'm working in electricity utility like ours, I get to know that equally people who have done statistics, people who have done ICT are going to be very major key players in a utility sector. So it brings an element of bringing other stakeholders in the utilities, not just those who did the core courses that are relevant to the products being sold in those utilities, but it brings the other players, the ICT people. Utilities nowadays employ people who have not just done core courses or disciplines in their respective products that they earn. So that is another revolution that utilities need to be aware of and need to embrace on the go. It's not a matter of fighting cross-discipline, but it's a matter of embracing and getting to a realization that technology has now brought people to work together. So it goes back even to the HR division. How do you now package the utility staffing to be able to work properly in a data and artificial intelligence era? That will be very, very important. And it is one of the things that is really happening in the utility. The final one that I really wanted to talk about is this data. How clean is it? And because you're going to derive insights from it, you are going to put very many formulas. You are going to invest on programming languages, R, Pythons, and Anaconda. But are you really basing this on a clean environment? Have you really mapped your grid components? Is that meter really that you have as a utility that is recording for you the energy? Is it matched with the right transformer? Is it matched with the right feeder? Is it matched with the right primary substations? So the data that you are going to rely on for forecasting, for theft detection, for the customers to be able to manage their power well or energy well, for you to be able to do predictive and curative maintenance, forecasting and planning, decision making. How clean is it with respect to a utility? Have you mapped it well across the grid? So data and AI, a game changer in the utility.
Okay. Thank you, Cleopas. I agree with you that it is a very interesting topic and we can discuss whole webinar about that. But okay, we are very near the end of our webinar and we are very short with time. So the last question was about how can Kenya ensure that capacity building and workforce development. And only if you want to add something about that, we mentioned about people and the importance of human capacity development. But if you have to add something about that, but very shortly, 1 minute.
Thank you very much. In terms of capacity development in any utility, it has to be relevant to the technology that the company is adopting. The capacity development should also look directly into the succession plan insofar as the average aging of the staffs who are there, so that as the technology advances, you bring multidiscipline in a utility to be able to sustain the technology that you saw adopted. So it's a matter of looking at the environment where you are, looking for the right skills, both for the future. But at the same time, as technology comes, you also need to know that the current workforce that you are having has institutional memory. So how do you retool them? How do you reskill them? How do you ensure that they are able still to be relevant even as technology changes and you require to move from point A to point B? So that's briefly what I can say on that very key aspect.
Okay, thank you, Cleopas. Anyone else? Oh.
Yeah, I think I could add something there, and it's probably a cross-cutting point, is that approaching smart metering and smart grid development in general should be thought out as a systemic shift And I think capacity building, even at where we produce the professionals. Look at our education system, should be able to provide not only a view of engineers working for utilities, it will also be able to come up with what has been highlighted as the demand for data scientists and statisticians, the need for social scientists and behavior experts, those who can work with driving user shift, as well as supporting that, and as well as people who can be able to understand and structure deals that would unlock the right finance and also build policies and frameworks that can support this transition. So I think looking at it as a systemic agenda addresses the capacity building component, and equally also looks at cross-cuttingly, because at the end of the day, it boils down to what Cleophas just said is, every technology aspect has to have the people component. So addressing the people component enables everything else, enables policy, it enables finance, and it enables technology for successful implementation.
Okay, thank you, Daniel. Jeremiah, if you have to add anything, or we will close.
Well, I think the skills and capacity building is critical. And if you roll out smart metering can outpace the workforce unless capacity building is permanent, is structured and continuous. And various ways, like for us, we have the training institute where we have regular training programs. Sometimes also you can embed AMI contracts with capacity building and skills development, so that as new technologies, new equipment come, then the staff can be trained as such, and then that is maintained. So we need laboratories, we call AMI digital grid labs, to support the continuous training. As this is a dynamic field, then it also needs, the training should be dynamic as well. So I think that is it. I think going forward now, we need professionals who are hybrid. They are power and they have data skills, what we call data professionals. Then they can work better. They embrace AI skills and digital skills. Then these are the kind of workforces that we require in the future, or rather to support these transitions that we are doing. Thank you very much.
Okay, thank you, Jeremiah. I'm sure that we have had a very valuable discussion today. We heard a lot about financial, technological, skilled people and policy aspects of smart metering and also smart grid. And it is clear that smart metering is not only a technological project. We agree that financial aspect is the most important in Kenya, the biggest barrier. We have an interesting solution to solve that with public-private partnership with telecom companies, other partners, and also that support of international finance institutions is very important. Very important first step is pilot projects and lessons learned from pilot projects to scale international programs. So we heard that it is very important to have aligned policies and strong partnership and collaboration between utilities, regulators, and all stakeholders in energy sector. At the end, I would like to thank Elite Africa for supporting and promoting Smart Talks with Jovan. My thanks go to Cleophas, Jeremiah, and Daniel for sharing their insights. And thank you to our audience for joining us today. So let's shape Kenya's sustainable energy future together.
Thank you.
Thank you.
Thank you, Jovan, for your time.